Welcome to Train Signal. In this video, we're going to learn all about binary numbers. Now first, before we get into the binary stuff, I got a question for you. What is this number right here? Go on, tell me. It's not a trick question. That's right, 3,482. But how do we know that? Well, we know that because we've learned that in the decimal numbering system, each column has a value, right? We have the ones column, the tens column, the 100s column, and the 1000s column. And then we take the number in each column and multiply it by its value. So here we have 3 times 1,000 being 3,000, 4 times 100 is 400, 8 times 10 is 80, and 2 times 1 is 2. We then add those numbers together and you end up with, well, we were right, 3,482. Alright, now, before you get upset and turn off the video, sounds like a bunch of double talk, I promise you that there was a purpose behind this, and this is going to help teach you how to work with binary numbers. So let's go ahead and take a look at the decimal versus binary numbering systems. First, we have the decimal numbering system, or what's also known as base 10. Now, every numbering system has a base, and the purpose behind the base, well, there's really two purposes behind the base. One is to come up with our column values. The values of our columns will always be the base to the 0 power, and then base to the first, base to the second, base to the third, etc., etc., etc. That's how we come up with our column values. The second purpose behind the base number is to define how many choices we have to put in each column. In other words, because it's base 10, we have 10 choices, the numbers 0 through 9. So if we then look at the binary numbering system, that is also known as base 2. Okay, so the base 2 tells us that we only have two choices for numbers, right? 0 or 1. All numbers in binary will be 0 or 1. In machine terms, very often that represents an on or an off. But then also our column values are going to be 2 to the 0, 2 to the first, 2 to the second. Now, you know what? Forget all that. That is way too difficult. I'm going to show you how to convert numbers by knowing how to add, subtract, and multiply by 2. So we're going to start off by coming up with our column values without having to worry about all these exponential numbers. The first thing you need to know is that any number to the 0 power is always 1. Okay, so the rightmost column value in any numbering system is going to be 1. And then all you have to do is multiply by the base value. So if we go back up here to decimal, we started with 1, and then forget the exponential numbers here. Forget all that. You've got 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000, etc., etc., etc. So let's go down here to the binary, and we start off with 1. And this is the complicated part. You have to know how to multiply by 2. If you multiply 1 times 2, you get 2. 2 times 2 is 4. 4 times 2 is 8. And if we continue on, we end up with 16, 32, 64, 128. Now let me stop there for just a moment. When dealing with IP addresses, that's pretty much all you should have to know is the column values from 1 through 28, or excuse me, 128. Now continuing on, 256, 512, 1024, 2048, and we'll stop there at 4096. I just wanted to take it out this far to show you that we could keep going on and on and on with these column values by just simply multiplying by 2. So let's see how to convert binary to decimal. Down here, I have an 8-digit binary number. It's a pretty simple one, right? 10101010. And up here, I have 8 column values. So what I need to do is I need to take this number and put it over here, just like we did with the original 3,482. So if we move that number under its column values, and then take each number and multiply it by its column value, well, again, we don't need to get into this fancy multiplication. The simple answer is 1 times anything is itself, right? So 1 times 128 would just simply be 128. And 0 times anything is 0. So anywhere you see a 0, we can just cancel that out. So the easy answer is anywhere there's a 1, just take those values and add them together. Right? So we end up with the 128 because there's a 1. We end up with the 32 because there's a 1. The 8 because there's a 1. And the 2 because there's a 1. And if we add those together, we end up with 170. So what that means is the binary number of 101010, I think I missed a 10 there, equals the decimal value of 170. Not a real big deal when it comes to converting binary to decimal. Matter of fact, most people find that to be pretty simple. Just take wherever there's a 1 and add them together and boom, you get an answer. But what tends to be a little more confusing is when we want to go the opposite direction. So let's take a look at that. Let's look at converting a decimal number to binary. Well, here we have that decimal number of 3,482 that we originally started with. And what you need to do to now turn this into a bunch of 1s and 0s is to write out your column values, which I have up here, until you've gotten to a number that is larger than the decimal number you're trying to convert. Because what you want is you want the largest binary column value without going over. See, 4,096 would be too much, right? So we need to jump down here to 2,048. That's the highest number without going over. What you do then is you put a 1 underneath that column, okay, which I've done that here. Here's a 1. And then you subtract that from the original number. So 3,482 minus 2,048. Well, just in case you're not that good at the subtraction, let's do this the long way. 2 minus 8, oh, you can't do that. So let's make that 12. Borrow from the 8, right? Make that 7. So 12 minus 8 is 4. 7 minus 4 is 3. 4 minus 0 is 4. 3 minus 2 is 1. And then you end up with 1,434. The next thing we need to do is, again, look for the largest column value without going over, which would be 1,024. And we're going to put a 1 under there. And again, subtract it from that 1,434. And you end up with 410. Now, the largest column value without going over would not be 512. Okay, this is too big. So we're going to go to 256 and put a 1 under there. Subtract it. We get a remainder of 154. So you need to put a 1 under 128. Take that away. You're left with 26. We now have to go all the way down to the column value of 16 because both 64 and 32 are too large. They're larger than 26. So we put a 1 under the 16 and take it away, and you end up with 10. Put a 1 under the 8, subtract it, you get 2. Put a 1 under the 2, subtract it, and you end up with 0. And that's significant when you get to a remainder of 0. That means you're done. And that number 0 is significant because that is the other value we can put in a binary number. And so what we need to now do is take all of the column values that don't have a 1. So we got this one and this one, here, here, and here. Now you'll notice that 4,096 does not have a 1 under it, but we don't need to put the preceding 0. We can start with the first positive value of a 1. And at this point we just plug in all the zeros. And boom, there you go. 1 1 0 1 1 0 0 1 1 0 1 0. So that means that 3,482 in decimal has a binary value of this big long string of 1s and 0s. Really not that bad, is it? Or maybe it is. If you find that this is difficult for you, you have the ability to use a calculator. And in all Windows operating systems, and on this particular system I'm on Windows XP, but if you go to your Start menu and you go to All Programs, Accessories, you'll find a calculator. And you look at this calculator and you might say, well, wait a minute. I don't know how I would convert between decimal and binary on here. Well, what you may not realize is that if you go to the View menu, you can select, see right now it's on Standard. We can select Scientific, and now we get a calculator that we can do this conversion with. So if I put in 3,482, right, we have that up here. You'll notice these buttons up here, right now it's on decimal. Well, if I click this button over here next to binary, watch this. Boom, there we go. 110.110.110.110, just like we have down here. Or if we want to convert the other direction, let me go ahead and clear that out. Starting in binary, if I were to put in 10101010, just like we had before, and then click on decimal, do you remember what the answer was? That's right, it was 170. So if these conversions are difficult for you on paper, feel free to use the calculator. I will tell you that on all the Microsoft certification exams, they do provide this calculator to you. So now let's see how this all relates to IP addresses. Well, each of the 4 numbers in an IP address is called an octet, or oct for 8, because it's an 8-bit binary number, each of the 4 numbers. So here we have an example of 192.168.10.101. Well, believe it or not, each one of those 4 numbers represents an 8-bit binary number. And as we talked about in binary, a bit is a 1 or a 0. So therefore, each octet can only have a number from 0 to 255. The reason why, if we take a look here, is you'll notice that the lowest binary number, which would be 8 zeros, well, that's of course going to have a decimal value of 0. But if we take the highest 8-bit binary number, which is all ones, and you'll see I've also put those up here, and I've also taken each of the 8 column values and I put them here, added them together, we end up with 255. So that's why every number you see in an IP address is always somewhere between 0 and 255. So let's take a look at an actual IP address. Here I have 192.168.10.101. Well, what we need to do is take each one of those 4 numbers and convert them to binary. So if we start off with the 192, you'll see here that 192 would convert to 11000000. Why is that? Well, 128 plus 64 would equal 192. All right, so now let's take 168, and 168 converts to 1010100. Again, because 128 plus 32 plus 8 equals 168. Now the 10 converts to 00001010, and finally 101 converts to 011000101. Now one thing I also want to point out is typically when you look at a number, you would not include the preceding zeros. In other words, 10 in binary is very often just known as these 4 digits right here. 1010, and that's it. Okay, we don't need the preceding zeros. But because we're talking about an IP address here, all 8 bits in the octet are significant. So you print out all 8 of them, including the preceding zeros. So the IP address of 192.168.10.101 in binary would be represented as, I'm not even going to say it, this big long string of numbers. So how about the subnet mask? Well, here I have an example of our subnet mask, which is 255.255.255.0. Well, that conversion is pretty simple, right? Because the subnet mask is all 255s and zeros, and we know that 255 is all ones, and we know that 0 would be all zeros. So this is what our subnet mask would look like. And if you put them all together, this IP address and subnet mask, as we typically see it, is seen by the computer as this long string of ones and zeros. Now, in a later video, we will get into more detail about the significance of the ones and zeros in the subnet mask and how we can actually not just have 255s and zeros, but that these ones all can stop somewhere in between the dots. It's called a variable length subnet mask, and we'll get into that in more detail in a later video. Okay, well at this point you should now be able to convert a decimal number to binary. You should likewise be able to convert binary numbers back to decimal. And most importantly, with those tools, you now know how to convert a decimal IP address to binary.